All right, let's get started. We're in week 1 and we're looking at the third activity on our lesson plan for the week. It is lesson 15.3, classify plane figures, and we're looking starting on page 493. Wrong page. On page 493, it says, a Venn diagram shows how sets of things are related. In the Venn diagram at the right, one circle has figures that are rectangles, and it's been labeled right here. Figures that are rhombuses are in the other circle. The figures in the section where the circles overlap are both rectangles and rhombuses. So if it's in the middle, it belongs to both groups, or it has the characteristics of a rectangle and of a rhombus. What type of quadrilateral is in both circles? And you might have a good idea just by looking what we would call that quadrilateral that's right there in the middle. So let's go down and look at these questions and think about them. What do I need to find? Well, I need to find what type of quadrilateral is in both circles, or we can say the quadrilateral, and I'm just going to put quad, in the middle. They're asking us to figure out what is a name for this shape. What information am I given? The circles labeled rectangles, it's a small line, and rhombuses. What is my plan or strategy? So my plan or strategy here is I'm going to think about the characteristics of each of those, what traits we have. Remember, if I'm going too fast, just pause the video and to catch up. What is true about all quadrilaterals? Okay, well, we know all quadrilaterals have 4 sides, 4 angles or corners. Okay. That's all it takes to be in the family of quadrilaterals. Quad meaning 4. Which quadrilaterals have 2 pairs of opposite sides that are parallel? Well, we call those, if we have 2 pairs, those are parallelograms. Parallel, parallel, parallelograms. Remember, parallel lines like those 2 L's right there. Which quadrilaterals have 4 sides of equal length? Well, that's a rhombus. Or rhombuses. Which quadrilaterals have 4 right angles? Okay, the key for if it has all 4 right angles, that's a rectangle. Rectangles, right angles. The quadrilaterals in the section where the circles overlap have, that page up here, have blank pairs of opposite sides that are parallel. Well, there's one pair and another pair up here, and then one pair and another pair. So it has 2 pairs of opposite sides that are parallel, blank sides of equal length. Well, looking at each of these, they have all of the sides are equal length. 4 sides of equal length. And now we want to know about right angles. They have 4 right angles. So what do we call this shape if it has right angles of a rectangle and the equal sides of a rhombus? That is a square. So squares are in both circles. Okay, let's turn the page. Page 493. There we go. So now we have a shape, and it says the Venn diagram at the right shows the figures Abby used to make a picture. Where would the figures shown below be placed in the Venn diagram? So on this side, this circle is labeled quadrilaterals. So that's 4 sides and angles. And this is polygons with right angles. So it doesn't have to have 4 sides. It can be any polygon, straight sides and closed, that has right angles or square corners. So we see all of these have at least one right angle in them. And then the ones in the middle have 4 sides and they have right angles. The ones over here have 4 sides but don't have right angles, and the ones over here have right angles but not 4 sides. 3 sides, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5 on that one. So we want to know, our question is asking us where we would place this shape right here. So let's fill in. What do I need to find? I need to find where the figure, that's what they're calling it here, where the figure goes. What information am I given? Okay, well, we have 2 circles, and one of them is quadrilaterals. I'll just put quad because that's, oh, refocus screen. Just realized I'm unfocused here. Sorry about that. I'm putting quad for quadrilaterals, and then we have polygons with right angles. Polygons with right angles. Okay, what is my plan or strategy? We'll say we'll analyze the characteristics. Okay, this is all about looking at these shapes and being able to look at the important parts of them, like parallel sides or right angles or how many sides. Those are all characteristics. So if we look at this shape right here, and we want to figure out where it belongs. First, let's see if it would belong within the circle that says quadrilaterals. So 1, 2, 3, 4. It has 4 sides, so it is a quadrilateral. So I'm just going to put a little check here. It's a quadrilateral. And then does it have right angles? Well, yep. There's a right angle right there and a right angle right there. These 2 angles are not. That one's an obtuse angle, and that's a little acute angle. So for solve, I'm going to say that it would go in the middle. Okay, it would go right here in this middle section because it is both a quadrilateral and it has right angles. It has 2 right angles. And we have some more questions down here about the shapes. They're at the top. It says, how many figures do not have right angles? So if I look up here, because I already marked them, that actually makes this a lot easier. All of these do have some right angles. These are the ones that don't. So there are 1, 2, 3 figures that do not have any right angles. How many red figures have right angles but are not quadrilaterals? Okay, so that means here are my figures that have right angles, but we want the ones that are not quadrilaterals, and these guys are. So we're looking at this part of the circle that doesn't overlap. And it's also asking for the red figures. So I see there is only one, that triangle that has a right angle right there. 1. What is a different way to sort these figures? So what is something we notice about these? We could make another grouping, or a different way we could label these. Well, you might come up with something different, but one thing that I notice is that we have some parallelograms. So I could have had a group that was parallelograms as a possible group. So why don't we just say that? Parallelograms could have been a different way to group, but we could come up with some more. All right, we're just going to go on now to page 495. Okay, it says Jordan is sorting the figures at the right in a Venn diagram. Where does this shape right here, green shape, go? Okay, first look at the sides and angles of these polygons. All right. Next, draw the polygons in the Venn diagram below. All right, so we're going to go ahead and put them where they belong. In our Venn diagram, we have polygons with right angles and polygons with all sides equal in length. Okay, so let's look at the first one. I see that it does have right angles, but it doesn't have all sides equal in length because there's too long, too short. So I would draw him right over here. Okay. And now we have this triangle. Oh, bring that down a little bit. We have this triangle here, and I don't see any right angles on him. Those are all smaller than square corners. So he's not going to belong in this circle, but he does have all sides equal in length. So I'm going to draw this triangle over here. And it's not perfect, but close. Close as I can get. All right, now we have this purple. Looks like a square to me. Now we have right angles. Yep. So he can belong in this circle. Does he also belong in this circle? All sides equal in length? Yes. So if he belongs in both, he goes in the middle. So I'm going to draw the square in the middle. He has right angles and all sides equal in length. Then we've got another triangle, different type of triangle. This one does have a right angle, but all sides are not equal in length. So I'm going to put him over here, make that right angle there, and then let's connect those two. All right. Now we've got this 5-sided, not a quadrilateral. 5 sides, that's a pentagon. 5 fingers to hold my pen, 5 sides on a pentagon. So this pentagon has some right angles. Ooh, do we have all sides equal in length? This is a little tricky. So I'm going to grab this piece of paper here and try to see if these sides are equal in length, because I'm not sure just by looking at my eyes. They kind of look like they might be. Oh, yeah, from that corner to there. Looks like it could be. Ooh, wait, I don't think it is. All right, so not all sides equal in length, but it does have right angles. So I'm going to put him over here, the pentagon. It looks like a house, right? Now we have a 1, 2, 3, 4, 5, 6, 7, 8 sides, an octagon. 8 sides on an octagon, like 8 arms on an octopus. And I can definitely tell not all sides are equal in length, but we do have some right angles here. Quite a few of them, actually. All right, so we have some right angles. This one's going to be fun to draw. It's not sides equal in length. Let's see. We have a long side here. Over, down, out, out, Oh, well, not exactly, but we can tell that's supposed to be that one. Right, now I've got this 1, 2, 3, 4, 5-sided pentagon. No right angles, but all of these sides are equal in length. So he belongs over here. This is what we would call a regular pentagon. It's regular if all the sides are the same length. It's irregular. That was an irregular pentagon, and this is a regular pentagon. Okay, so it's over here. And then this one right here, if you turn it and look at it, you can tell that these are right angles here. You can always test if it's a right angle because you can take the corner of your piece of paper and it fits right in there. And then all sides are the same length. So basically, we just made a square, but it's going like this. It's turned on its side. In fact, it's easier if I just draw it like that. Okay, so there's that one. Whew, that took quite a while. The figure above this one has 4 sides of equal length and 0 right angles. So the figure goes in the circle labeled, so he doesn't go in the right angles, he goes in this one. Polygons with all sides equal length. Where in the Venn diagram would you place this shape? So first, I see that it does have right angles, so it would belong over here. But all of the sides are not equal in length because this is definitely longer than that one. So he belongs in the polygons with right angles. Right. Okay. Now question number 3. Eva drew the Venn diagram at the right. What labels could she have used for the diagram? Where would each label go? So let's look at the circle on the left, and I'm just going to write the word left circle. And let's decide what characteristics all of these have. Well, in the left circle, I see that, let's look at number of sides first. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And that would have to include this part right here. 1, 2, 3, 4, 2, 3, 4, 1, 2, 3, 4. Everything that's in this circle has 4 sides. And what we call polygons with 4 sides, quadrilaterals. Right, on the right circle, let's put right. On this one over here, what can we say about these? Well, they're not all quadrilaterals. These ones are because they went in that circle. But let's look at the angles. I notice everything inside this circle has at least 1, sometimes more, right angle. And everything outside of here didn't. So these are polygons with right angles. Okay, and then our last question says, draw and label a Venn diagram to show one way you can sort a parallelogram, a rectangle, a square, a trapezoid, and a rhombus. All right, let's make 2 circles over here. Let's think about what characteristics we're going to put on here. So it has, all of these are quadrilaterals. but we need to think of something that some way that will be a little bit different. So parallelogram, rectangle, square, trapezoid, rhombus. Well, all of these except for the trapezoid have two pairs of parallel sides. So let's go with that, although I don't know if I would have anything in the middle that way if I did it just parallel side, two pairs of parallel sides, or not. Let's go with that. Two pairs of parallel sides and one pair of parallel sides. So we would put a parallelogram, maybe one that looks like this, parallel, parallel, parallelogram. A rectangle, let's go with a traditional too long, too short side rectangle here. A square. The trapezoid would only have one. And the rhombus would have two pairs of parallel sides. Rhombus has to have 4 equal sides. Okay, so we don't have anything in the middle the way I set this up, but there could have been maybe a different way we could have classified these and put them in there, but that's the one I came up with. There wasn't a one right way on this one to do. All right, thanks for listening.